All right, guys. Yep. Here's one stop drawer. All right, guys. We're going to go on and start looking at the review sheet today. So for problems 1, 2 through 4, we want to find the indicated root, the nth root of A. And for any of these here, 4 and then 20,736. Now at this point here, we could plug it into either calculator. So we can say 4th root of 20,736, which is 12. Now, just as a reminder, anytime we take the even root, we have to add the plus or minus. So since we took the 4th root, we have to add the plus or minus. If we take an odd root, we do not. So number 2, we don't have to do the plus or minus. So we're going to take the 9th root of 512. It is indeed. So this here, since we took an odd root, we don't add it. It's all about the root, the index. Now 3, we would have the plus or minus because we're taking in even root. 4, we would not because that is an odd root. Are there any other questions on 1 through 4? Because if you don't put the plus or minus, if it's needed, I will take all points because, again, it is 2 roots, 12 and negative 12. Because we took an odd root, because negative 12 to the 4th is 20,736. 12 to the 4th power is 20,736. Now the next one, 2 to the 9th, 2 to the 9th is our 512. Now if we said negative 2 to the 9th, we don't have 512, we have negative 512. So the positive and negative case do not work for that there. Only works with even roots. We only add plus and minus on even roots, not odd roots. Any other questions on 1 through 4? Yeah. 5 through 8, evaluate each expression. So if it's saying evaluate, just plug it in. So we can say 8 to the negative 2/3. And 8 to the negative 2/3 is 1/4. Any questions on number 5? 6, we can say 1/4 to the negative 5/2. It is indeed 32, and with any of these here, I would plug them in exactly as you see them. So like 8, we'd say 16 to the 2nd power. Well, we need 2 sets of parentheses. 16 squared, and this is 2 to the negative 1/4, which is 1/4. So if we do have something like this here, I would type it in exactly as we see it and go from there. And if we type number 7 into the calculator, we should get 1/27. Any questions on 5 through 8? Questions on 9 through 12? We plug them in. 974,231. 974. We get this here if we plug it in. Now it says round to the nearest 4th decimal place, so we go 4 out, so 9.95958. So we would round the second 5 to a 6, giving us 9.9566. We could do the next one, 816 to the 1/9. parentheses 816 to the 1/9 is 2.1063. The number after 3 is 0, so we just get 2.1063. Any questions on any of these here? We ready for the next set? Questions 13 through 16. Simplify each expression using the properties of exponents. Now, if we could plug it into the calculator, we can always try and see if we get a nice number. If we do, that is the correct answer. So we could try the first one. Parentheses 6 to the 3rd to the 1/4. 3.833658625 is not the correct answer because we are not putting any of these as decimals. So we'll actually need to use the properties of exponents. Now the properties of exponents, powers of powers, multiply. So 3 times 1/4 is 3/4. So the correct answer for this here is 6 to the 3/4. Now, if you wanted to check that in the calculator, we could. We could say 6 to the 3/4. Now, we get the same answer as what we originally started with, so 6 to the 3/4 is the correct answer, and this is a way to verify. So our answer for this here is 6 to the 3/4. Any questions on this here? Now, if we look at 14, 9 over 12, we'll simplify because both have a common factor of 3. So we can simplify 9/12 to 3/4. Now, just like the first one, we're going to apply this negative exponent to it. So powers of powers multiply, which would give us 3 to the negative 3/4 over 4 to the negative 3/4. Now we can't leave the exponents negative, so to make them positive, we're going to move the 3 from the numerator to the denominator, from the top to the bottom, giving us 3 to the positive 3/4. We can do the same thing for the 4, take it from the denominator to the numerator, making the exponent positive. And that is it there. And we could have plugged 9/12 to the negative 3/4 into the calculator. It would have given us a decimal, so we would have had to work this one out anyways. Any questions on 13 or 14? 15, we can try plugging this into the calculator. Fraction 2 to the, I believe it was 2/3, yes? Times 16 to the 2/3. All over 4 to the 2/3. Now it gave us a whole number, no decimals. So it works out that it is 4. Now since everything did have the 2/3, we would pull it out and then simplify from there. Let's look at number 16. Now we could try plugging this in, and most likely it's not going to give us a nice answer. 4 to the 1/2 times 4 to the negative 3/2, and this is all to the negative 1/4. Gives us a decimal answer, so we're going to actually have to work this one out. Now, whenever we multiply like bases, we can add the exponents. So we're going to add 1/2 and negative 3/2. Now we don't have to do this by hand. We could do it in the calculator. We could say 1/2 plus -3/2 gives us, guys, okay? Questions on this one so far? So since we're multiplying like bases, the 4 and 4 are the same, we can add the exponents. So we add 1/2 and -3/2. And 1/2 plus -3/2 is -1. Now at this point here, we're going to multiply our exponents. Powers of powers multiply. And -1 times -1/4 is 1/4. So 4 to the 1/4 is our final answer. Any questions on 1 through 16? For problem 17 through 20, use the properties of rational exponents to simplify. Especially if it is square roots. We could try plugging it into the calculator, simplifying. All radicals in the yellow calculator will simplify and give us the answer. So the square root of 2 times square root of 72 is 12. So for this here, it's equal to 12. Now, even if they told it was something other than 72, say 74, it would simplify to 2 square root of, because the yellow calculator so for those there, if it has a root other than 2, we have to do it by hand. Now, we could try any of these here. So for 18, the 5th root of 486 over the 5th root of 2. So we could try this in a calculator. 5th root of, what was it, 436 over the 5th root of 2. Right. 86, thank you. I was wondering why that didn't work out. 86 is 3. So if it works out nicely, we get a number without a decimal, we can just use the calculator. Because what we would have done otherwise, since both of them have the same root, we can combine them. And the other main reason we combine them is because 486 is divisible by the denominator. It's divisible by 2. And if we divide this by 2, we get 243. At this point here, we would do the factor tree for 243, which is going to be 3 and 81. 81 is 3 and 27. 27 is 3 and 9, and 9 is 3 and 3. Since we do have 5 3s, 3 to the 5th, so this is saying that we have the 5th root of 3 to the 5th, which is indeed 3. So since it's simplified nicely, we have this here. Any questions on 18 before we look at 19? Now, if we look at 19, they all have a cubed root. So we can put them all together. It'd be 6 times 72 divided by 2. At this point here, we can simplify what's inside the radical, 6 times 72 over 2. So we can plug that into the calculator. 6 times 72 all over 2 is 216. So we're looking at the cubed root of 216. And again, just like the last one, we can do the factor tree of 216. Well, 2 will definitely go into 216, and it will go in to it 108 times. Well, 2 does go into 108 54 times. 54 is 2 times 27. Well, 2 won't go into 27, but 3 will. It'd be 3 and 9, and 9 is 3 and 3. So it's telling us we have 3 groups of 2s and 3 groups of 3. So we can really say that this is the same as the cubed root of 2 cubed times 3 cubed. Well, the cubed root of 2 cubed is 2. Cubed root of 3 cubed is 3. And 2 times 3 is 6. And the calculator, the cubed root of 216 is 6. So the calculator would have done that there. Questions on this here? Any questions on 1 through 19? Yeah. We ready for number 20? Now 8 is the same as 2 to the third. So we can rewrite this, or rewrite 8 as 2 to the third, because if we did the factor tree, it'd be 2 times 4, and 4 is 2 times 2. We have 3 2's, telling us this is 2 to the third power. Now whenever we have like radicals, they're both fourth roots. We can multiply what's inside of them together. So we have the fourth root of 2 to the third times 2 to the third. Since we're multiplying like bases, we can add the exponents, giving us 2 to the sixth. Now we can simplify this here. We know we will need to because the exponent inside the radical is bigger than the root we are taking, 4. And so this tells us we can take groups of 4 2's outside of the radical. How many groups of 4 2's can we take away or remove? How many times can we remove 4 from 6? Once, leaves us with 2. So we can say this is the same as 2 times the fourth root of 2 squared, which is really saying 2 times the fourth root of 4. Now it does work out that this is the exact same as 2 square roots of 2, but I will take either one of these here. Any questions on 1 through 20? Questions on 21 through 24? Which one of these do we want to look at in particular? 21. So to solve this one here, we would multiply the complex conjugate, or the actually irrational conjugate. We multiply top and bottom by the denominator, but change the sign in the middle. And we went through doing that in class. Now, we also saw that we could plug it into the 30xs and get an answer as well. So if we plug it in, hit enter, it tells us that this is the same as the square root of 3 minus 1 over 2. So let's see here. 11 minus 9 minus second square root 6 is, it should be plus. 99 plus 11 square root of 6 all over 75. So it should be plus. Yep, I'll just need to fix that. But these here, we can plug it into the 30xs. If you plug it into the graphing calculator, it will give you a decimal, and that's not the correct answer. Any questions on these here, 21 through 24? They might not always come out with a fraction, but the 30xs will solve them. Any other questions on 21 through 24? 25 through 30. Now 25 through 28, we need to get the terms that have the radicals or fractional exponents to be the same. So looking at the first one, we need both of these to be 3 to the 1/3. Now the second one is already as 3 to the 1/3. So we need the first one to be written as 3 to the 1/3. But what times 3 is 24? Eight times 3 is 24, yes? Can we take the third root of 8, or 8 to the 1/3? Eight to the 1/3 is 2. Because what we're doing here, because we have 8 times 3 to the 1/3, which is the same as 8 to the 1/3 times 3 to the 1/3. Well, 3 to the 1/3 we need for them to be the same, but 8 to the 1/3 is 2.
To report to Coach Shawver's room at this time. Assessi Pintry, Tanner Revis, Riley Shelley, and Olivia January. Thank you.
So we move the 2 out. Now we have 5 times 2, and 5 times 2 is 10. Now since our numbers here are the same, we can subtract the numbers in front. So 10 minus 4 is 6 times 3 to the 1/3. So this here is our final answer. Any questions on number 25? 26. We need these radicals to be the same. Now the first one has the cubed root of 2. So for us to be able to subtract these, both of them need the cubed root of 2. Now at this point here, we need to see what times 128, or what times 2 is 128. That would be 64, because 64 times 2 is 128. We can't take the cubed root of 2, and that kind of was told to us because the other one had the cubed root of 2. We just need to see if we can take the cubed root of 64. And the cubed root of 64 is 4. So what that tells us, guys, that the cubed root of 128 is 4 times the cubed root of 2. Now, since both of them have the cubed root of 2, we can subtract the numbers in front of them. 5 minus 4 is 1 cubed root of 2, or just the cubed root of 2. Any questions on 25 and 26? Now, as I said at the start, the yellow calculator works very well with radicals, and we've seen that. So 27 squared of 6, what was it, 27, 6, what was it, 7, is square root of 6. And the same thing is true with 28. Since they're both square roots, we could plug it into the calculator, not the graphing, the yellow calculator, and we would get our answer. Any questions on 25 through 28 before we look at 30 and 29? So we will look at 30 first. Now with 30 and 29, we do need to combine like terms before we simplify the radical. Now with this here, whenever we divide like bases, space it forward, we subtract the exponent. So n to the 18th over n to the 2nd would be n to the 18 minus 2. P to the 7 minus -1 would be our other variable. Now if we simplify these exponents, 18 minus 2 is 16. 7 minus -1 would be 8. Now at this point here, we need to see how many groups of 8 we can take away from n to the 16th. How many groups of 8 can we remove from 16? 2. Do we have any left over? No. Because 16 minus 8 is 8. 8 minus 8 is 0. We have 0 left over. With our other variable, p, how many groups of 8 can we remove from p to the 8th? We can remove 1. Are there any left over? So the final answer is n squared times p. Now technically we would need absolute values around the p, but I'm not going to count off for that. We will leave it as n squared times p. Now for number 30, we're taking the 6th root of g to the 6th, h over h to the 7th. Now, g to the 6th, there is no g on top and bottom, so we leave it alone. But we could simplify the h's because there's 1 on top and 7 on bottom. 7 minus 1 is 6, and it stays on bottom. Because it's bigger on bottom, it stays on bottom. How many groups of 6g can we take away from g to the 6th? 1. In the denominator, we can take 1 group. So we have g over h. Now technically, we would need absolute values around the whole thing, but g over h is fine. That is the correct answer. Any questions over this here? Any questions over 1 through 30? (31) and 32, find f plus g of x, f minus g of x, f times g of x, and f divided by g of x. For this one here, we'll look at 32. Now the first part of 32 we're going to look at is f plus g of x. This is the same as f of x plus g of x. And in our case here, f of x is 4x to the 5/4. G of x is 2x to the 1/2. Is x to the 5/4 the same as x to the 1/2? Are they like terms? No, so can we combine these two? No, so the final answer is this here. So that is f plus g of x. Now we also have to find f minus g of x. Now f minus g of x is the same as f of x minus g of x. F of x is still 4x to the 5/4 minus 2x to the 1/2. Is x to the 5/4 and x to the 1/2 like terms? No, they weren't the same on the last one. They're still not the same. So this here is f minus g of x. Any questions on addition or subtraction? Now the next one we need to do is multiplication, f times g of x. Well, it's the same as f of x times g of x. And f of x is still 4x to the 5/4. g of x is 2x to the 1/2. Now when we multiply two together, the first thing we can do is 4 times 2 is 8. Now when we multiply like bases, x and x, we add the exponents. So we would do 5/4 plus 1/2. Now we don't have to do this by hand. We can do this in a calculator. And it would indeed give us 7/4. So f times g of x is 8x to the 7/4. And lastly, we have division, f divided by g of x. So that'll tell us that we have f of x divided by g of x. So f of x in our case is 4x to the 5/4. G of x is 2x to the 1/2. Now the first thing we can divide with this here is the 4 and 2. 4 divided by 2 is 2. And whenever we divide like bases, we subtract the exponents. So we'd have 5/4 minus 1/2. And again, at this point, we can do this in a calculator. I believe it'll give us 3/4. And that would be it for division. Any questions on 32? Guys? Any questions on 1 through 32? 33 and 34 are not difficult, but I'm not going to include them on the test. Now, the next thing we're going to look at is our composite functions. Any of the composite functions, we always work from the inside out. So we can look at number 35. So the first thing we're going to do is plug x into g of x. And if we plug x into g of x, 2x plus 5. Now it brings us to our next step. Now every x in f of x is going to be replaced with negative 2x plus 5. So 7, instead of 7x, we have 7 times negative 2x plus 5 minus 2. Now at this point here, we do need to simplify, so we can distribute the 7. 7 times negative 2x is negative 14x. 7 times 5 is plus 35 minus 2. So that'll give us negative 14x plus 33. This is f of g of x. Any questions on number 35? Same thing for 36. Do we want to look at 36, 37, or 38? 37, f of x. So the first thing we're going to do is plug x into f of x, which would give us 7x minus 2. It would give us that function. Now at this point here, we're going to plug 7x minus 2 into every x in f of x. So we would have 7, instead of x, we'd have 7x minus 2 minus 2. Now at this point here, we would distribute the 7. 7 times 7x is 49x. 7 times negative 2 is negative 14 minus 2. Well, negative 4.
Williams, Nathaniel Byers, and Quincy Chunsteady.
Negative 14 minus 2 is negative 16. So f of x is 49x minus 16. And with any of these here, always work it from the inside out. Doesn't matter what we start with, work from the inside and keep applying it as we go through until we've applied it to every single one. Any other questions on 35 through 38? Are you ready for the next set? (39 through 41). So this time, instead of using x, we're using a number. Do we want to look at 39, 40, or 41? 41. 7x minus 2 is our f. G is negative 2x minus 5, or negative 2x plus 5. So with any of these here, we always work from the inside out. So we're just doing the same process again and again till the very end. So the first thing we're looking at is g of 3. So we're going to plug 3 into g of x. G of f of g f. Now at this point here, negative 2 times 3 plus 5. We could work this out by hand, or negative 2 times 3 plus 5 is negative 1. Now again, we're working from the inside out, so this time we're going to take f of negative 1. So we'd have 7 times negative 1 minus 2. Most likely. Now at this point here, we're taking 7 times negative 1 minus 2. Again, we're just doing it in the calculator. 7 times negative 1 minus 2 is negative 9. So we replace that with negative 9. So we have f of g of f. So g of f of g of negative 9. And again, at this point here, we plug in negative 9 into g of x. So it'd be negative 2 times negative 9 plus 5. And again, at this point here, we can just plug this into the calculator. So negative 2 parentheses negative 9 plus 5 is so now we're taking f of 23. So it's 7 times 23 minus 2. Now in the calculator, we can say 7 times 23, guys, minus 2 is and lastly, we plug this into g of x, so it'd be negative 2 times 159 plus 5. So negative 2 times 159 plus 5 is and that's it. So again, there's not a lot to this problem. It's just very repetitive. We're working from the inside out. We take it one step at a time, and we plug the number in. We can plug that just straight in to the calculator. So each one of these here, we're just plugging into the calculator and getting our answer. There's a lot of steps, but each of the individual steps is not that bad. It's just plugging it in. Any questions on 1 through 41? Are we good with 1 through 41? Now, inverses. We'll look at 42, and unfortunately, well, we will pick this up tomorrow. So unfortunately, we did not finish this today. So we're going to finish the review sheet tomorrow, which means your test is Monday. All of your homework is also due Monday. If you're not here Monday, it means you're having to take it in Champ on Tuesday. If you do not come into Champ anytime next week, it will be a 0 until you get it finished.